Okay, welcome to today's lesson on light intensity. I want you to write down the date and the title and the LO, please, and then I want you to try the starter task. So pause the video here and I'll continue in 5 seconds. Okay, the answers. So the simple equation for photosynthesis is CO2 plus H2O goes to C6H12O6 plus O2. So we've got carbon dioxide, water, glucose and oxygen, but remember this isn't balanced. So we have to put a 6 in front of everything other than glucose and that makes it balanced. Okay, the next one was number 2 was name the 3 limiting factors for photosynthesis. So I'm going to do number 2 and question number 3 at the same time. So the 3 factors are light intensity and the graph should look like that, carbon dioxide and the graph should look like that, and heat and the graph should look like that. So give yourself marks for those starter tasks, please. So light intensity, this is carrying on from the photosynthesis practical that we did before half term. So if we were to plot the number of bubbles compared to distance on the graph, we would have a curved line, but the distance is not what's affecting the rate of photosynthesis, it's the light intensity. So if you did a graph that looked like this, that wouldn't be correct because we're not testing the distance, we are testing the light intensity. So we need to figure out what our light intensity is, and we're going to go through that now. So the relationship between light intensity and photosynthesis is complex. This is because light intensity involves the inverse square law. Now this sounds really terrifying, but I promise you it's not, and we're going to practice it. So as the distance from the light increases, photosynthesis decreases. So the further away the light source was, the less bubbles there were because there wasn't as much photosynthesis. This is an inverse relationship. So as one goes up, the other one goes down. However, the relationship between distance and light intensity is not linear. So that means it's not a straight line. The light intensity increases or decreases in inverse proportion to the square of the distance. Now, all that means is a fancy scientific way of saying if you double the distance of light, if you double the distance, there should be a comma there, light intensity falls by a quarter. There we go. Okay, so if you double the distance, light intensity falls by the quarter. So it's inversely proportional, so as one goes up, the other goes down. So the distance is going up, the light intensity is going down. If the distance is doubled, the light intensity falls by a quarter. So relative light intensity is 1 divided by distance squared. I want you to write that in your book, please. Light intensity is 1 divided by distance squared. Okay, so we have some sample data here. The distance has been recorded, but we now need to calculate the light intensity. So using the formula, we're going to calculate the light intensity for each distance. Now I've done the first one for you, and this is how I did it. So 10 centimeters is 0.1 meters. So when you're doing light intensity, you want to do it in meters. So to convert centimeters to meters, you divide by 100. Okay, so 10 centimeters equals 0.1 meters. And then for light intensity, you should have this written down in your book. It's 1 divided by distance squared. So we've got 1 divided by 0.1 squared equals 100. So the light intensity for the first one is 100. Now I want you to try the rest for yourself, please. So pause the video here and I'll put the answers up in 5 seconds. Okay, answers are on the screen. So what trips a lot of people up is that they do it in centimetres. It should be done in metres. So to convert all of these to metres, you divide by 100. So the second one would be 0.2 metres. So you do 1 divided by 0.2 metres squared, and you should have got 25. And then 1 divided by 0.3 metres squared, you should have got 11, and so on. So please check your calculations and correct any that you got wrong. So using your own data that you collected from the simulation, plot a sketch graph of the light intensity against the mean number of bubbles. So try and do that graph, please. I know that you probably don't have graph paper at home, so that is why it's a sketch graph. So just do it as best as you can. It doesn't need to be entirely accurate because you can't make an entirely accurate graph on lined or plain paper, but just do your best, please. So in previous lessons, we have already seen that light intensity graphs should look like this. So it should go up to a certain point and then it should plateau off. I want you to compare your graph with this and describe any differences. Suggest what you could do that would allow you to draw a graph that looked more like this. So how would you change the experiment? Okay, that is all for today's lesson. I hope you all have a wonderful day.